Jack says if adding 7 and subtracting 7 go in opposite directions, then adding -7 and subtracting -7 should also go in opposite directions as well. Jill says, I don't know, Jack. That would mean if you start at 4, then add 7 or subtract -7, you end up at the same place. Let's create an argument that supports or disproves Jack's claim. We can think of adding and subtracting 7 as moving in opposite directions on the number line. So 4 plus 7 is equal to 4 minus a -7. So if we take a look at our objectives here, we see that 4 plus 7 would give us 11, but if we're adding -7, we would go in the opposite direction. I also know that 4 subtract 7 is in the opposite direction. Well then, therefore, these two pieces here would move in the opposite direction, just as adding and subtracting 7 moves in opposite directions. So 4 minus 7 and 4 plus a -7 are also equivalent. Since 4 plus 7 and 4 minus 7 move in opposite directions, and 4 minus a -7 and 4 plus a -7 moves in opposite directions. So Jack's claim is correct. Complete the table with yes or no. Pause the video and see if you can't see or identify if these claims are equivalent or not. -5 plus 8 and -5 plus a -8 are not the same. -5 minus 8 and -5 plus 8. So thinking about -5 minus 8, we would start at -5 and we would subtract 8 more, so we would be getting more negative. Whereas -5 plus 8 means we need to move in the positive direction, so we're going the opposites. If I have -5 and I add -8, is that the same as -5 minus 8? Yes, it is. And further, -5 minus a -8 means we're going to move in the opposite direction of what we think. And -5 plus 8 would be moving in the positive direction. So ideally, they're both moving in the positive direction. So let's verify this with positive and negative chips. Let's start with the first one. It was -5 plus 8. So here's -5. 1, 2, 3, 4, 5, and we want to add 8 to it. 1, 2, 3, 4, 5, 6, 7, 8. So I see that we have a positive 3. Is that the same as -5? 1, 2, 3, 4, 5. So this has to be negative, so I need to turn them to negative. And then adding 8 more negatives. So 1, 2, 3, 4, 5, 6, 7, 8. So adding 8 more negatives. 1, 2, 3, 4, 5, 6, 7, 8. So we added 8 more negatives to the 5 that we already have. So we have -13. So these are not the same. The next one was -5 minus 8. So I have -5, 1, 2, 3, 4, 5. I need to take away a positive 8. I don't have a positive 8 here to take away. So what we're going to do is manipulate this a little bit by adding in groups of 0, particularly 8 groups of 0, so that I can take away a positive 8. And I know that seems silly, but I don't have a positive 8 to take away. So the only thing we know how to do at this point is adding groups of 0. 1, 2, 3, 4, 5, 6, 7, 8. because we know that adding 0 doesn't change anything. So I have 8 groups of 0 here, and I have my -5 that we started with. So if I have -5, now I can subtract 8. Subtract a positive 8. 2, 3, 4, 5, 6, 7, 8, leaving me with -13. However, if I have -5, 1, 2, 3, 4, 5, and we want to add 8, a positive 8, 1, 2, 3, 4, 5, 6, 7, 8, I see that this result is positive 3. So that's why the first two both were not equivalent. The third one down is -5 plus -8. So we have -5 plus -8. 1, 2, oops. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the second one is -5 minus 8 more. But that's the same as the last one, so we didn't have enough, so -5 minus a positive 8. We don't have a positive 8 to get there, so we need to add a group of zeros. Oops, just kind of moving everything around here. Okay, so a group of zeros. So that I can take away a positive 8, leaving me with -13, which is what the left-hand side said. So these were equivalent before I took them away. Okay, so then if I start the very bottom row, we have -5, I need to take away -8, but I don't have -8 to take away. I only have 5. So I would need 3 more groups of 0 so that I have enough pieces to take away a positive 8, or take away -8. So here we started with -5. I need to take away -8, but I only had 5 to take away, so we needed to add 3 more so that I would have 8 to take away. So if I take away a -8, I see I'm left with positive 3. Is that the same as saying -5, 2, 3, 4, 5, adding 8, 1, 2, 3, 4, 5, 6, 7, 8. Here then I've created 5 groups of 0 which would disappear, leaving us with just 3 positives. So these are the same. I really like using the positive negative chips because it really solidifies if we should have a positive or negative answer. It's a different way to think about manipulation and visual models. Number lines are great too, but I feel like you've probably worked with the number lines, so you're super comfortable, and positive negative chips might not be so comfortable with you at this time. The additive inverse. Did you know we can turn a subtraction problem into an addition problem? So here I have a set of subtraction problems. Let's turn them into addition problems, something that we're more comfortable with perhaps. So 8 minus 3 is the same as 8 plus a -3, or 7 plus a -13, or -15 plus a -6, and -2 plus 9. Oh, this should be plus a -9. No, plus 9. Go ahead, try using positive and negative chips to verify that these statements are in fact true. So pause the video, play around with your chips a little bit to see if these are true. Subtraction gives the same result as adding the additive inverse or opposite of a number. The inverse relationships between addition and subtraction help us to add and subtract with integers. A meteorologist recorded the temperatures for Denver, Colorado for 1 week, but forgot to use numbers. Use the written statements to determine the actual daily temperature as compared to the previous day. So on Monday it was 0. On Tuesday it was half a degree colder. So if we were at 0 and it's half a degree more cold, we would be at -1/2 a degree. On Wednesday there was no change, so it would stay at -1/2. On Thursday it was 11.5 degrees colder. So if we're already at -1/2, half would bring us to -1. If we go 11 more, here'd be 2, 4, 6, 8, 10, 11. So -12 degrees. If we're at -12 degrees and now we warm up 8 degrees, here we would have, and notice it goes by 2's, so -12 plus 8, so 1, 2, 3, 4, 5, 6, 7, 8, bringing us to -4. On Saturday, it was 7 degrees warmer. So if we're at -4 and it is 7 degrees warmer, 1, 2, 3, 4, 5, 6, 7. So positive. That's why from -1 to 0, it's a whole jump. So bear with me here. All right. So -4, 1, 2, 3, 4, 5, 6, 7. So +3 degrees. Got to be careful how they've got it outlined there. And then if we're at 3 and it's 6 degrees colder, 1, 2, 3, 4, 5, 6, -3. The relationship between adding and subtracting holds for the set of rational numbers. What patterns do we see when we're adding and subtracting positive and negative numbers? Let's start with the pattern when the operation and the sign are the same. So let's use positive negative chips to show 3 plus a +2 and -5 minus a -2. Okay, so we started with 3 plus a +2. And then we have -5, take away -2. So when I take away -2, I'm left with -3. And when I have 3 add a +2, I'm left with 5. So in both instances, I see that I'm actually adding. Two like signs mean we move in the positive direction or add. Let's move on when the operations of the signs are different. -3 plus -2 and -2 minus a +3. So here I have -3 and I want to add in -2, which gives me -5. So I'm actually subtracting more. And -2 plus a -3 also means that I'm subtracting more. So two unlike signs means move in the negative direction or subtract.